Hi, we'll be now taking up congruency rules of SSS and RHS with more on some more property on the triangles. So I just write one of the first theorems that we are going to take. It says if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. That means if it's there, one triangle has three sides equivalent to those of the rest of the three sides of another triangle, they will be congruent by SSS rule of congruency. This is SSS congruency. Another one, which is the last one, I think it's left, that is RHS congruency rule. It says if in two right triangles the hypotenuse and one side of one triangle are equal, so the hypotenuse, that means it has to be one right, RH, that is has to be one right angle, it has to be the hypotenuse equivalent, and one side also are equivalent to the hypotenuse and one side of the other triangle, then the two triangles are congruent. So this is RHS rule of congruency. Let's try taking up few questions based on this. And let us first start with very simple questions. Therein I will be drawing a figure here. I need to tell you that these are not accurate figures. You can see I'm just drawing them and putting the word problems here and say that these are two equals or not. So they are not accurate figures. It says AB is equal to CD. We'll mark it on our figures as well. AD is equal to BC. We have to prove that triangle ADC is congruent to triangle CBA. Okay, AB, this one is equal to this, and it says AB is equal to CD. Oh, that's so simple. In these two triangles, if you see AB, okay, I'm taking up ADC, I'll write CD is equal to AB, I'll write BC equal to given AD and the line AC, that is common in both the triangles. So by SSS, three sides of one triangle equal to three sides of the other triangle, thereby making these two triangles congruent by SSS rule. Let me now take up one question wherein I move to a more spacious screen. I draw one more figure here. This proves they do need figures. Most of the questions are with figures. You'll also come across questions when you have to draw the own figure. It says this is P and Q, this is A and B, and here this is a point of intersection I need to draw. This is C. The question says AB is a line segment. P and Q are points on the opposite sides of AB such that each of them is equidistant from the points A and B. You can see that in the figure. We'll mark that as well. We have to show that the line PQ is perpendicular bisector of AB. Perpendicular bisector of AB means we have to show one of the angles here to be 90 degree as well as AC to be equal to BC. Let us see if we can prove this. Okay, PA and PB was given equal to it. We have to show PQ perpendicular. Now let us take PAQ and triangle PBQ. We know AP is equal to BP and AQ is also equal to BQ. It had said, why? See, it says P and Q are the points on the opposite sides of AB such that each of them is equidistant. So P is equidistant from AB as well as Q is also equidistant from AB. Now the line PQ is common, so we write PQ is equal to PQ. Therefore triangle PAQ is congruent to triangle PBQ by SSS congruency. Right? Now when this happens, the angles can be made equal, right? This angle will be equal to this angle by CPCT. So we write angle APQ is equal to angle BPQ by CPCT. Now we take these two triangles, take triangle PAC and triangle PBC. If we prove the congruency of these two triangles, we can prove AC to be equal to BC. Because to prove PQ as a perpendicular bisector, we need to first prove AC equal to BC, and then we prove one angle, that is PCB or PCA, this PCA to be 90. So in triangle PAC and PBC, again we can write was given AP equals BP. PC was common, and the one we now calculated that, or we now not calculated, we actually derived by CPCT, APQ. If I'm writing APQ, it is equivalent to writing APC equals BPC. So it is by SAS rule. Now triangle PAC is congruent to triangle PBC. Here I can write SAS congruency. Now when we write by SAS congruency, these two triangles are congruent, thereby making AC equals BC. So it is bisected now. We now have to prove only the perpendicular part, right? Now this is derived by CPCT, as well as it says angle PCA will also be equal to angle PCB. That will be derived by CPCT as well. Now if you see in the figure or in the triangle PAB, angle PCB plus angle PCA also makes 180 degree. So if I substitute PCA with PCB, I am getting 2 angle PCB as 180 degree. So angle PCB will be 180 by 2, that is 90 degree. Now we have already proved AC to be equal to BC. We have now proved this to be a 90 degrees. So obviously the other side also being 90 degree. So PQ is proved to be perpendicular bisector of AB in the given figure. Hope you got it very clearly. Thank you.